Hello, this video is for Algebra 1. It is for Chapter 1, Lesson 3 of the Algebra 1 textbook. This lesson is titled Multiplying and Dividing Real Numbers, where our objective is to multiply real numbers and to divide real numbers. The vocabulary for this lesson is reciprocal and multiplicative inverse. So who uses this? Well, hot air balloon pilots can determine how far away from liftoff they will land by using multiplication, and we'll see that in example 4. So they tell us here that when you multiply or divide two numbers, the signs of the numbers determine whether the result is positive or negative. And they give us a chart here. Here's a column for the numbers, and then here is the column for either the product or the quotient. Product is what we get whenever we multiply two numbers together, and a quotient is what we get whenever we use division and we divide one number by another number. The result is called the quotient. So we're talking about multiplying and dividing here, which actually matches up to exactly what our title of our lesson is. So if both numbers are positive, then the answer is going to be positive. And if both numbers are negative, then again the answer is going to be positive. However, if one of the numbers is negative and the other one's positive, then the result is going to be negative as well. So let's go ahead and look at that on the next page of multiplying and dividing real numbers. In words, we say, whenever it comes to multiplying and dividing numbers with the same sign, we say that if two numbers have the same sign, then their product or their quotient is positive. Here's a couple examples. 4 times 5, they're both positive. The answer is positive, positive 20. Here we have a quotient of positive 5, and that comes from negative 15 divided by negative 3. Well, they're both negative, so the answer is going to be positive. Now, multiplying and dividing numbers with different signs works a little differently. If two numbers have different signs, their product or quotient is a negative number. So here's a couple examples. We have a positive times a negative, and 8 equals a negative. And here we have a negative comes first this time. Negative times positive equals negative. Same works for division. Take a negative number, divide it by a positive number, we get a negative answer. And likewise, if you take a positive number, divide it by a negative number, then you're going to get a negative answer as well. Now, I got a little memory device for this. There's a couple of them. First of all, if we go ahead and use a triangle here, that's if you were to create a little triangle, and then in one corner you put a plus sign, and up in the other two corners you put a negative sign, and then if you were to cover them up, and how might I cover them up? Let's do this. So if you have a negative times negative, picture putting your fingers over those. Negative times negative, what's left over? You see the positive sign. So negative times negative is positive. But if you had a negative times a positive, if you cover the positive with one finger and a negative with the other finger, what do you see left over? Well, you see this negative over here. Now, you might be saying, well, what about positive times positive? Well, you've been doing positive times positive numbers for quite some time. So I think most of us know that a positive times a positive is going to equal positive. Now, another little memory device story I've been telling for years that I kind of like. It's interesting, and most people like it too. Suppose you're creating your own little town. You're just starting out, and you need people to come to your town. So whenever someone comes to town, we're going to call that a plus sign. That's positive. Somebody comes to town, that's good. If somebody leaves town, then, well, that's bad. And we're going to say that's a negative sign. Now, there's good people in the world, and there's bad people in the world. So for good people, we're going to go ahead and put a plus sign. And for bad people, we're going to put a minus sign. So let's look and see how does this possibly help us with understanding multiplication or division of positive and negative numbers. So check this out. If a good guy comes to town, then that is good. If a good guy leaves town, then that's bad. If a bad guy comes to town, well, that's bad. But if a bad guy leaves town, then that's good. So you can see here that that's kind of a memory device. I actually have some students that tell me, as silly as it is, sometimes they actually think through that one. So at any rate, that's the come to town, leave town, good guy, bad guy example. Okay, let's look at example 1. Multiplying and dividing signed numbers. Find the value of each expression. So we have a negative 12 times 5. So it's a positive times a negative, so we know the answer is going to be negative, and 12 times 5 is 60. On the next one, we have 8 times negative 5 over 4. So let's go ahead and write 8 as 8 over 1, because we can take any number that's not a fraction and turn it into a fraction simply by placing it over 1, because every fraction is a division problem, and any number divided by 1 is equal to itself. So 8 over 1 is equal to 1. And you can see that they've done that conversion here of 8 over 1. And we've got our negative 5 over 4. So positive times negative is negative, so we see the negative sign. And 8 times 5 is 40. 1 times 4 is 4. 40 divided by 4 is 10, and it still remains negative. Now, personally, I kind of like to keep my negative signs up with the numerators. So if I were actually working this on paper, I probably would have done 8 times this number here. I would have thought of this as 8 over 1 times negative 5 over 4. And I would have just moved my number sign, my negative sign, up in with the numerator. And probably what I would have done before I ever multiplied this is I would have realized that 8 and 4 share a common factor of 4. 4 divided by 4 is 1, and 8 divided by 4 is 2. Then 2 times negative 5 equals negative 10. And 1 times 1 is 1. And any number over self is equal to itself. So I get negative 10 that way. 35 divided by negative 5. Positive times negative. So what is that? Good guy leaves town. That's bad. At any rate. So positive divided by negative is negative. 35 divided by 5 is 7. Negative times negative is positive. 11 times 4 is 44. And finally, negative times positive is negative. 6 times 7 is 42. Helpful hint. Let's look at this helpful hint here. Because multiplying by 1 does not change a number's value, 1 is the multiplicative identity. And we call it the identity property because whenever you multiply any number times 1, you're going to get that number back. It's not going to change the value. We call that the identity property because the number kind of like sees itself as it goes through the process. Just like you look in the mirror, what do you see? You see a reflection of you. You see yourself. Whenever you look at your driver's license or an ID card, you see a picture of you. We call it an identification card because it looks like you. Identification, identity, you see the word relationship there? So that's why we call it the identity property, and to be exact, it is the multiplicative identity property. 1 is the multiplicative identity property. Just a little bit of review. What is the identity property of addition? 0, right? Any number plus 0 is equal to itself. Two numbers are multiplicative inverses if their product is the multiplicative identity. That is to say, exactly what we're getting ready to read here. But the interesting thing is that the identity property always leads, or the inverse property always leads back to the identity property. Two numbers are reciprocals if their product is 1. Product means to multiply. So if you have two numbers and you multiply them together and you get your answer is 1, those two numbers are reciprocals of one another. And they're inverses of one another because they get you right back to the identity property, which is 1. See what I'm talking about? Inverse property gets you to the identity property. A number and its reciprocal are called multiplicative inverses. So the inverse property of multiplication, we have an example here. In words, we say the product of a non-zero real number and its reciprocal is 1. Non-zero because it can't be a 0. So here we have 4 times 1/4 is equal to 1/4 times 4, and that equals 1. You can even see it there, kind of picture 4 over 1 times 1 over 4. It's going to end up being 4 over 4, and any number over itself is equal to 1. Here we have negative 3 times negative 1/3. That's equal to negative 1/3 times negative 3, and we get a positive 1. We want to leave it as a negative, okay? And you might also think, well, you're just flipping the fraction, right? Because if 4, and I write that as 4 over 1, times 1 over 4 equals 1, and these two are reciprocals of each other, and so if I were to ask you what's the reciprocal of 6, you would tell me that the reciprocal of 6 is 1 over 6, which technically 6 is 6 over 1, so we just flipped it, right? If I ask you what is the reciprocal of 1 over 24, you'd be like, oh, okay, I just need to flip it and do 24 over 1. Or another way to say that is 24. However, if it's positive, you want to leave it positive. If it's negative, you want to leave it negative. Now, there will come a day where there will be a process of taking the reciprocal, that is saying flip it, and then make it a negative or make it a positive, the opposite of whatever sign it is. We would call that the opposite reciprocal. Now, we're not going to use that here, but someday in geometry, whenever you're dealing with the slopes of perpendicular lines, you're going to need that. So, but don't confuse them there. Maybe I shouldn't have mentioned it there, but just a little bit of a preview for algebra someday. Because people are saying, when am I ever going to use this? So, for any real number a, where a is not equal to 0, we say that a times 1 over a is equal to 1 over a times a, and those two always have a product of 1. To divide by a number, you can multiply by its multiplicative inverse. So to divide by a number, you can multiply by its multiplicative inverse. And that comes in handy here whenever it gets to dividing fractions. So we have, let's go ahead and read here. You can write the reciprocal of a number by switching the numerator and the denominator. A number without a denominator has a denominator of 1. So that's like example B. We'll look at that in part B. So negative 4/5 divided by negative 8/15. Well, it's negative divided by negative, so we know it's going to be positive. And sure enough, our answer is positive down there. So let's go ahead and rewrite the problem here. And this is what you know of as keep, flip, change. If you've heard of keep, flip, change before, KFC, and we're not talking about the chicken restaurant either. K is for keep. That means keep the first fraction the same. F is for flip. Flip the second fraction. And C is for change the sign. And no, they're not talking about positive and negative signs. They're talking about changing division over to multiplication. You will use KFC for dividing fractions. So with that said, let's go ahead and look at what we got here. So we're going to keep the first, negative 4/5, negative 4/5. We're going to flip the second. That is to say that we are taking the reciprocal of it. So negative 8/15 becomes negative 15/8. And we're changing the sign. This is division, and here we don't see a times, a multiplication sign, but the fact that this is contained inside of parentheses, and there's no plus or minus sign there, we realize that this means multiplication. So let's go ahead and rewrite this, numerators over denominators. So negative 4 times negative 15. See what I'm talking about? How the negative sign kind of jumps up into the numerator here. See the negative sign kind of jumped up in there. Negative sign kind of just jumps right up into that numerator there whenever they rewrote it. So negative 4/5 becomes negative 4 over 5. Negative 15/8 becomes negative 15 over 8. Multiply straight across with fractions, right? So negative 4 times negative 15 is 60. Negative times negative is positive. 5 times 8 is 40. 60 over 40 will simplify to 3 over 2 by dividing both of those by 20. 60 divided by 20 is 3. 40 divided by 20 is 2. Now, I myself would probably have done this just a little bit differently, but I want to show you why this works. Because every fraction is a division problem. And for the purpose of I'll go ahead and leave it as negative. We'll leave these as negative. I wasn't going to just think of it without the negative signs, but we'll go ahead and roll with it, right? So let's write this as negative 4 over 5. And it's divided by negative 8 over 15. So I'm going to go ahead and move those negative signs up in the numerator. Now, remember that every fraction's a division problem. So I could actually write this as negative 4 over 5 divided by negative 8 over 15. And what I'm showing you here, if you can grasp this and understand why it works the way it works, you'll actually know more than a lot of math teachers do. There are math teachers that don't know why keep, flip, change works. They just know that it works, but they're not able to explain why it works. And I'm going to show you now how it and why it works. So we know that any number over 1 is equal to itself. So if we could get the denominator to be 1, then we could just deal with what's in the numerator, right? Well, how do we get to 1? We multiply times its reciprocal. So let's go ahead and multiply negative 8 over 15 by negative 15 over 8. And yes, I know I left the negative sign up there, but we can go ahead and do that. That's okay to do that. You can move it back and forth from numerator to denominator. That's a fair move. But whatever we do to the denominator, we have to do to the numerator. So let's multiply it by negative 15 over 8. Now, down here, these are reciprocals of one another, so they're going to equal 1, right? Let's just kind of move all this over here. Those are going to equal 1. Now, what do we have up here? We have negative 4 over 8 times negative 15 over 8. And we know that anything over 1 is equal to itself, so we can just get rid of this part here. Correct? Now, look what's happened. Let's erase all this so we can see in between. Let's put our KFC here. KFC. Did we keep the first? Indeed we did. Negative 4 over 5. What did I do? I got in a hurry. It's supposed to be a 5. Let's fix that. There we go. Did we keep the first? Indeed we did. Negative 4 over 5, negative 4 over 5. Did we flip the second? Negative 8 over 15, negative 15 over 8. The 15 and the 8 switch places. Did we change the sign from division to multiplication? Indeed we did. And then we could just work it out from there to get our answer. This is why keep, flip, change works. Because every fraction is a division problem. So we're actually writing fraction over a fraction. Then we're using the inverse property of multiplying times its reciprocal in the denominator so that we can get to the identity property of 1. And with any number over 1 is equal to itself, we're left with what's in the denominator, which what's left in the denominator? Keep, flip, change. I might take an extra 5 minutes to explain all that, but that's good stuff, whether you believe it or not. So let's go at B. Remember what it said over here? If a number doesn't have isn't a fraction, we could write it as a fraction by placing it over 1. So we take negative 4 and put it as negative 4 over 1. And then we change the mixed number to an improper fraction. First of all, mixed number is a number that has a whole number with a fraction. So 9's the whole number, or actually integer, to be exact. So an integer with a fraction. So 9's the integer, 1/4 is the fraction. Now we're going to change that to an improper fraction. Improper fraction is a fraction where the numerator, the top number, has a greater value than the denominator. That is to say, the bottom number, right? So we get there by multiplying. Here's how we convert those, because we're going to be doing some of these in activity. So how this works is we'll call A is taking the place of 9. We're going to write this as A and B over C, where A is the integer, B is the numerator, and C is the denominator. In order to change this to a fraction, we have to do the value of C times A and then add the value of B. And then all of that's going to be over the denominator of C. So, follow me here. 9 times 4 is what? 36, right? Plus 1 is 37. And the denominator stays the same. So that's all they did, is they did this times that plus this over that. This times this plus that over that. 4 times 9, 36, plus 1, 37, over the denominator, 4. Now we could go ahead and work this out here. Let's keep the first, negative 4 over 1, it's negative 4 over 1. Flip the second, 37 over 4 becomes 4 over 37. Change the sign from division to multiplication. And now we can go ahead and solve. 4 times 4 is 16. 1 times 37 is 37. And a negative times a positive equals a negative. So let's do some division here. So let's go ahead. I'm going to write this as negative 3 over 4. I'm going to throw that negative sign up there with the numerator. Let's do divided by, and then negative 9. Let's write that as a fraction. We can make that as negative 9 over 1, right? So let's keep the first, negative 3 over 4. Flip the second, negative 1 over 9. Notice I'm leaving that negative sign in the numerator. It's okay, same value. And change the sign, multiply times. Now I do notice that 3 and 9 share a common factor of 3, so let's cancel that. Or not really cancel it, but we're dividing 3 by 3 to get 1. And 9 divided by 3 is 3. Now we can do negative 1 times negative 1 is positive 1. Negative times negative is positive. And 4 times 3 is 12. On the next question, we got 3 over 10. 3 over 10. And we're going to go ahead and keep the first, 3 over 10. Flip the second, so negative 6 over 5 is going to become negative 5 over 6. Change the sign from division to multiplication. Now, 3 and 6 share a common factor of 3. 3 divided by 3 is 1. 6 divided by 3 is 2. 5 and 10 share a common factor of 5. So let's divide 5 by 5 and we get 1. And 10 divided by 5 is 2. So now we have a 1 times 1 is 1. And it is a positive times a negative. So this is a negative 1. And 2 times 2 is 4. Negative 1/4. And the last one does have a mixed number in it. So we'll go ahead and work that one. So let's do negative 5 over 6. I'm just throwing that negative sign up there into the numerator. And here I need to change this mixed number to an improper fraction. So 3 times 1 is 4 plus 2 equals 6. And the denominator stays the same. So that's 3. So we'll take one step at a time. So 6 over 3. Silly me. That's not the correct answer. What am I talking about? Let me back up. I realized that wasn't right because 6 over 3 is equal to 2, and they would have just wrote 2, right? So let's try this again. 3 times 1, I did 3 plus 1, didn't I? 3 times 1 is 3 plus 2 equals 5. So that is 5 over 3. There we go. And I'm going to go ahead and keep the division there. I haven't flipped it yet. So now let's do keep, flip, change. Keep the first, negative 5 over 6. Flip the second, 3 over 5. Change the sign, multiplication, or division to multiplication. And can we do any canceling? Wow, we can do a lot of canceling. Check this out. 5 divided by 5 is 1, and 5 divided by 5 is 1. So we factored out 5 out of there. And 3 divided by 3 is 1, and 6 divided by 3 is 2. So there we go. What are we left with? This is a negative divided by a positive. So it's negative and positive, so the answer is going to be negative. 1 times 1 is 1. 2 times 1 is 2. So our answer is negative 1/2. Let's look at and talk about the number 0. The number 0 has special properties for multiplication and division. Properties of 0. In words, we say multiplication by 0. The product, remember product is whenever we multiply. The product of any number and 0 is 0, such as 1/3 times 0 is 0. 0 times negative 17 is 0. Anything times 0 is 0. So no matter what your number is, and we'll use A to represent any given number. Any number times 0 is going to equal 0, or 0 times any number equals 0. On the next one, divide. 0 divided by a number. The quotient, again, quotient deals with dividing. The quotient of 0 and any non-zero number is 0. So if 0 is in the numerator, and it's being divided by some number, the answer is always going to be 0. Or we could write it this way. 0 divided by some number equals 0. So if you see something like this, you don't have to do any math. You just know the answer is 0. Now, interestingly enough, it's a little different if 0 is the denominator. If division by 0, well, division by 0 is what we call undefined. You can't do it. Well, actually you can. It's just undefined is what we call it. It's just not really an answer. For instance, I can divide $0 among 6 people. How much does each person get? $0. But I can't divide $12 among 0 people. I have $12. I'm going to give it to 0 people. How much does each person get? Well, there's no people to give it to. You see, dividing by 0 is undefined. You can't do it. So we just say that that's undefined. Okay, example 3, multiplying, dividing by 0. Multiply or divide if possible. So 0 divided by some number. Well, remember, in division, the number that's being divided is the top one. So 0 divided by 16.568 could be written this way as well. If 0 is the numerator, then the answer is 0. Here we have some number they're trying to divide some number by 0. Remember, this is what we call undefined. And any number times 0 is equal to 0. I think we pretty much got that covered. Let's skip these examples here. Let's move on to hot air balloons, the thing we've been waiting for, right? Everybody's been waiting for the example about hot air balloons. So recreation application, just in case you ever decide to go hot air balloon riding. A hot air balloon is taken for a 2.5-hour trip. The wind speed and the speed of the balloon, interestingly enough, this balloon apparently travels at the exact same speed as the wind. I did not know that. But the speed of the wind is 4.75 miles per hour. The balloon travels in a straight line parallel to the ground. How many miles away from the liftoff site will the balloon land? Well, first find the distance. We have to find the distance traveled at a rate of 4.75 miles per hour for 2.5 hours. To find the distance, multiply rate by time. So rate times time gives us distance, and you'll see that later on in the future. Rate times time equals distance. This means that we could go ahead and, in order to find out the rate of something, we could always divide distance by time. And if we want to find out the time of something, we could always divide distance by the rate. This is very, very important formula. That we call this a formula. Very important formula to remember. So plug in your values. 4.75 times 2.5. Positive times positive gives us a positive. So we end up with 11.875. So the hot air balloon will land 11.875 miles from the liftoff site. Here we have in our exercises, find the value of each expression. Vocabulary. How do you find the reciprocal of 1/2? You flip it, right? 2 over 1. Find the value of each expression. So negative times negative is positive. 72 divided by 9 is what? 8. Positive 8. And let's go over this one here. Negative divided by negative is negative. And 7.2 times divided by 3.6. Well, I happen to know that 36 is 1/2 of 72, so the answer is going to be 2. We're just dividing it by 2. Or we're dividing this by 36 to get 2. There you go. Let's look at, let's go ahead and do divide here. Good, because we got to make that 5 a fraction, right? Make it 5 over 1, keep the first. Let's flip the second, make that 7 over 5. Let's change the sign. 5's are going to cancel each other, factor 5 out. 1 times 7 is 7. And we don't want to squeeze that. 7 and 1 times 1 is 1, so the answer in 7 over 1 equals 7, so 7's the answer here. Kind of tight space. Maybe I should have worked it off to the side. Let's do that with this one over here. So negative 16 over 25. Keep the first. Now we're going to flip the second, right? So negative 4 over 5. So we're going to put negative 5 over 4. And change the sign from division to multiplication. Now, 16 and 4 share a common factor, 4. So let's factor 4 out. 4 divided by 4 is 1. 16 divided by 4 is 4. And let's factor the 5 out of the 5 and 25. 5 divided by 5 is 1. 25 divided by 5 is 5, or 4. There we go. So we end up with negative times negative is going to give us a positive number, right? And 4 times 1 is 4. And 4 times 1 is 4. And 4 over 4 equals 1. Interesting, because, check this out. We could have simplified 16 over 25 by dividing each of them by, no, 1 divided by 4. Did I mess up someplace? Hold on. I just realized what I did wrong. What I did here was 25 divided by 5 is not 4. 25 divided by 5 is 4. I'm trying to get in too big of a hurry. So that can happen sometimes. So 25 divided by 5 is 5. So 4 times 1 is 4. 5 times 1 is 5. The answer is 4/5. And then our 0 ones. Anything divided by 0, this is undefined. We can't do that. Anything times 0 is 0. 0 divided by anything is 0. And you can't divide any number by 0, so that's undefined as well. All right. So that concludes all of my instruction for textbook lesson 1-3, multiplying and dividing real numbers. Thank you.